For most of human history, cities have been slow things. They grow brick by brick, year by year, generation by generation. Empires rise faster than their cities can be built. Wars end before reconstruction even begins. And even today, in the age of machines, a single skyscraper can take a decade to complete. But what if that limitation is no longer real? What if the slowest part of civilization construction has already been solved quietly, experimentally, and far from public attention? Modern cities are not limited by imagination. They are limited by time. Architects can design entire megacities in weeks. Engineers can simulate earthquakes, wind loads, and climate decades into the future. Urban planners can map transportation, energy, and population growth down to the meter. But when it comes to actually building those cities, humanity still relies on an ancient formula: raw materials, human labor, and years of assembly. That gap between design and reality is where the secret technology enters. At the center of this idea is something deceptively simple: construction that behaves more like manufacturing. Not buildings assembled on site, but cities produced. Imagine structures that are printed, folded, or assembled by autonomous systems. Not over years, but over days. This is not science fiction. Around the world, experimental systems are already reshaping how physical space can be created. Large-scale 3D construction printers can now extrude entire building shells directly from digital files. Walls, foundations, even internal channels for wiring and plumbing formed in one continuous process. What once required hundreds of workers now requires a handful of technicians and a machine that never sleeps. But printing concrete is only the first layer. The real breakthrough comes when modular architecture meets artificial intelligence. Instead of designing one building at a time, AI systems can generate thousands of optimized structures simultaneously, each customized for terrain, climate, population density, and energy use. These structures are broken into standardized modules, manufactured in controlled facilities, and then transported to the site like components of a machine. When they arrive, autonomous cranes, drones, and robotic assemblers do the work. No delays, no weather stoppages, no human fatigue. A neighborhood can rise in weeks, a city district in months, a megacity in a few years. At that point, construction stops being a bottleneck and becomes a strategic weapon. This is why governments are paying attention. Instant cities solve problems that politics cannot. Housing shortages, refugee crises, post-disaster reconstruction, rapid urbanization. Instead of temporary shelters, permanent infrastructure can appear almost overnight. Power grids embedded directly into structures, water systems printed into foundations, transportation corridors pre-planned and assembled with millimeter precision. But there is a deeper implication most people miss. If cities can be built instantly, they can also be replaced instantly. Urban permanence disappears. A failed city is no longer a centuries-long mistake. It is a version update. And that changes how power operates. Control no longer comes from owning land for generations. It comes from controlling the systems that can deploy cities on demand. This is why the technology is not advertised loudly. Because the first civilization to master instant urban deployment doesn't just build faster. It reshapes geopolitics. Military bases become cities. Economic zones appear where trade routes shift. Entire populations can be relocated without collapse. Cities stop being organic history and start becoming infrastructure. And once that happens, the real question is no longer can we build cities instantly. It is who decides where they appear, who controls their design, and who gets to live inside them. Because the future of civilization may not be built slowly. It may arrive fully formed, overnight,